The issue with machine learning-based systems being designed by training versus intentional design raises a significant issue when you attempt to introduce that technology into a traditional software safety V cycle. In a traditional V, there's requirements and design on the left of the V and verification validation on the right side of the V. If you use a machine learning-based system with inductive training, there are no requirements, and there is no traditional design. For example, if you're building a machine learning-based system to detect people, there's no place where the designer says, here's what a person looks like. There's a head, and there's a torso, and so on. That never happens. You just show the system a bunch of pictures of people and say, these are all people, figure out what it means to be a person. So there's no intentional design, and more importantly, there's no insight into what the machine learning system is really learning. It just learns how to come up with answers that have a good statistical correlation to the training set. Well, that's all well and good if it seems to work, but how do you validate it? The point of the V is not simply to randomly test. The point of the V is that the tests on the right side correspond back to the left side and say, you meant to do a certain thing, and sure enough, you did it. Well, sure, there's some element of this in that you have a testing data set and you say, well, the machine learning system seemed to learn what we wanted it to learn because it did well on test inputs. But that's not quite the same as the V, largely because you cannot explain why it works. And so you have no confidence that it's working for the right reason, as opposed to random statistical chance just happens to get lucky on the particular training data and the particular testing data. The result is you have a system that's inscrutable and in practice can be quite brittle. Dealing with this brittleness in validation is a significant issue in ensuring the safety of autonomous vehicles.